8.2 Distribution of the sample proportion. So let's describe the sampling distribution of sample proportion. So simply put, it's basically like the classical method. You take the number of favorable outcomes and you divide it by the sample size. And then you just take huge samples, or not huge samples, a large amount of samples over and over, and you plot those samples on a distribution graph. So it's the exact same formula. Since sample proportions are unbiased, the mean of all sample proportions is equal to the actual proportion. So it's basically the same thing as the mean. The average of all the means is equal to the mean of the population. So it's the same thing, same concept. So let's describe the sample distribution of a sample proportion. So apparently, and this is a parameter statistic I found online. 0.76 of homeowners, or 76% of homeowners, support higher assessment of their houses. So if we take sample sizes of 10, 25, and 60 and measure the proportion of each one that supports higher assessments, on the x-axis you plot the proportions and the y-axis the density, so you can calculate the area under the curve, which represents a probability due to the law of large numbers. I don't know what's the law of large numbers here. I don't know how I put that. But find the distribution, shape, center, and spread. So distribution will just be mean, I believe. Spread is going to be the standard deviation. Center is going to be the mean. The shape should just be normal, because we're only focusing on normal bell-shaped distributions right now. So here's the formula. I'm not sure why these formulas are that, but the higher the number of samples, the more normal the distribution looks. I'm also not sure the logic behind that. But the center equals mean, which is the average of all sample proportions, and the spread is equal to the square root of the proportion times the complement of the proportion divided by the number of samples, which I think was calculated using variance as well. But note that the data must be obtained randomly. Independence, each one sample size must be less than 5% of the total population, because if we don't do that, then when we take the next position, so let's say we do a proportion or a sample, let's say we take a sample of 30 out of 100. That's 30%. So let's say there's a population of 100 people and we survey 30 of them. Let's say there's a population of 100 people and let's say we survey 30 of them. So that means if we do one, and we interview one, the next one will be over 29, and so on and so forth. And it won't be random distribution, because the proportion will become less and less as the sample size increases, or as the sample size takes up more than 5%. So if the sample size takes up more than 5% of the population, then it should not be included in a sample proportion distribution. Due to sampling without replacement. So unless you replace the person each time, then you can do so. But it must be less than 5%. So you can do sample size divided by total population size to see if it exceeds 5%. And the sample must be large enough to complement a normal distribution using the formula. Sample size times times proportion times complement of proportion greater than or equal to 10. Other words, you expect 10 successes and 10 failures. And I'm not sure how this formula works, but the proportion times the complement of the proportion should give us the probability of a failure and a non-failure using the independence multiplication rule. But I'm not sure how that works. Simply put, you would use all these formulas. The square root of the proportion times 1 minus proportion divided by the number of the sample size to get the spread, or basically the error of proportion. So here's how we compute probabilities of sample proportion. In a random sample of 120 Americans, what is the probability at most 12% have hearing trouble? So 12% as a proportion would be 0.12, and 15% is the mean, so we will be 12 minus 0.15, and then we find the standard deviation using the MP1 minus P formula, or the P times the complement of the proportion divided by the sample size to get that, and then you get the standard deviation, find the z-score, and then use the probability distribution z-score graph again. So that's simply it, and yeah.